A thin circular coin, as good as a disc or a plate, of a given mass and a radius 4 by 3 centimeter. Initially in the XY horizontal plane, the coin is tossed vertically up in the Z direction, and then it rotates as it moves up, reaches a top point, and then again keeps rotating and gets back to the initial position. Amazing question. Now see, it is given an impulse. Now let's note the data down. A thin circular coin of mass 5 grams. That means this has a mass 5 grams. Radius is noted 4 by 3 centimeter, and initially in the xy plane is given an impulse of j, root of pi by 2 into 10 power minus 2. Noted. The coin spins about its diameter. Now see, the coin spins about its diameter. Now the diameter is, let's say, this one. It rotates about this, that is, this is the omega that we are going to apply about this axis. And moves along the plus z direction, and that means it simultaneously has a vertically up motion as well. As it rotates, it translates. Rotational motion and translational motion both are going to apply in this question. Now by the time this coin reaches back to its initial position, it completes how many rotations? Given g is equal to 10. This is how we are going to solve this question. Let us say we are going to apply the impulse as a change in momentum. Now if I apply a change in momentum, let's say to this particular coin, then the j, which actually is a value of delta p, that means capital M into delta v. Now initial velocity of this was equal to 0 meter per second. So therefore this is going to result into simply an mv, a momentum value finally. Therefore, this velocity is the velocity with which it begins the translational motion v. And therefore, this particular v can be written as j by m. This v is the initial vertical velocity, and as it goes to the topmost position, the vy value at that point becomes 0 and is equal to v minus gt. The t is the time taken to move only up, and therefore Vy being equal to 0 can be written as V minus Gt, and T is equal to time of only ascent. Let us remember this is equal to V by G, and V is equal to J by M. Therefore, J by mg can be easily calculated. We will not calculate it right now. We will do it all at the end. Now, let's keep this as a result noted. Now, this impulse also does one more thing. Just as it provides an initial velocity to this coin and it translates up, it also does one more thing. It provides an angular momentum here, because this impulse is basically a momentum value and applied at a perpendicular arm length of 2 by 3 centimeter. Therefore, about the center of mass, about this center of mass position, the angular momentum about the center of mass, which is equal to, let's say, I of x, this is, let's say, the direction of x, this is the direction of y, and this is the direction of z. Let these be the directions, and therefore I of x into omega is the angular velocity is equal to the j value into small r. And why j value? Because that is equal to m into v into r. So therefore this provides us omega. Now but how much is ix? Here we have to apply perpendicular axis theorem. Now observe this. I of z, I of x and I of y, they are related on a perpendicular axis theorem basis. Iz and Iy and Ix will be all related. And how will they be related? This is the axis which is perpendicular to both. Therefore, Iz is equal to Ix plus Iy plus this Iy. Now, Dear, this particular coin being circular, the moment of inertia about x-axis and moment of inertia about the y-axis shall be equal for coin. Now therefore, the Ix or Iy value is going to be equal to Iz by 2. And how much is Iz? Iz is the moment of inertia of a plate about its central axis, and which is equal to mr square by 2 all upon 2. Therefore, Ix is going to be equal to Iy is going to be equal to mr square by 4 applicable about this diametric axis. Therefore, mr square by 4 into omega is equal to, let's say, j into r. And this gives us omega is equal to 4jr by mr square. 4jr by mr square. This is basically 2 pi by capital T, where capital T is the time period of one rotation, to be noted T equal to time of one rotation. Only one rotation. Therefore, capital T is equal to 2 pi mr square by 4jr. From this calculation, 2 pi mr square by 4jr. This is going to be the value of capital T. And this capital T, if multiplied into n by 2, because while going up, I will have n by 2 rotations while going up, and another n by 2 rotations while coming down, will produce total n rotations. So let's say this one time period into n by 2, one time period into n by 2 for n by 2 rotations should be equal to time of ascent. This is the central equation, and the time of ascent can be used, and this particular thing can be used, and now we can have the calculation going on ahead as like this. 2 pi mr square by 4 jr into n by 2 is equal to T, that is J by mg. Let's cancel out things as much as possible. This 2 goes. Nothing else. Everything else would be stored, and let n now is equal to 4jr makes it 4j square r. 4j square r. Pi m square r square g. Say this. 4j square r and pi m square r square g. This is the calculation for n. This is the calculation for n. And if we calculate this, we are going to get n is equal to 4 times j square. 4 by pi, let's say 4 by pi. Now j square. 4 is gone, pi is gone. Now j square, how much is that? Pi by 2 into 10 power minus 4. So j square is taken. Now 1 by m square. M square is 5 grams, means 25 into 10 power minus 6. So m square is taken. Into 1 by 10. G is taken. Now small r and capital R. Small r and capital R have a ratio of half. So 1 half into 1 by capital R, that is 1 by 4 by 3. So that makes it 3 by 4 into 10 power minus 2. This longer calculation, see, this is not long. We will solve this very easily. Say for example, pi is gone. 2 brings 2 here, 2. 2 by 25. So this is taken. And what else? Another 2. So into 2, this is taken. Into 3 by 4. So this is taken. What remains? Powers of 10. 10 power 2, effective 10 power 1, effective 10 power 3, effective 10 power 3. Once again, for a check, 10 power 2, 10 power 1, 10 power 3. So, I think we have taken everything. Pi goes, we have 2, 25 is taken, 2 is taken, 3/4 is taken. Let's solve this. So, what happens is this 2 goes, And we have 3 into 1000 by 100. Sis. 25 into 4 is 100. 100,000, and that means this is pure 30. That means n is equal to 30 rotations, and this is the answer to this question, and this is how it was solved. Thank you for your patience. See you more in the next discussion on physics. Stay subscribed, stay revised.